All right, this is screencast number 3 for investigation 9A. We've answered questions 1, 2, and 3, and now we're at the paragraph above question 4. So let's see, let me scroll it up so you guys can see. Go ahead and take your highlighter and highlight what I've gotten highlighted. It says, with time, the wave patterns of the upper air westerlies changes. We mentioned that in the last screencast. These changes may involve a change in the number of waves, the wavelength, or the amplitude of the waves. I'm not concerned with you knowing all of that. Just know that the patterns of those upper air westerlies are going to change with time. At one extreme, shown in figure 2A below, so this is figure 2A, at one extreme, the upper air westerlies blow almost directly from west to east with very little signs of ridges or troughs. So there's a little bit of curvature, but not much. They almost blow directly west to east. This westerly flow, this one, is described as zonal. Okay. At the other extreme, shown in figure 2B, the upper air westerlies blow in huge north-south loops with high amplitude ridges and troughs. So we get a lot of waviness. That's a meridional. This westerly flow pattern in this case is called meridional. Okay. The circulation patterns displayed in 2A and 2B are opposite extremes of many possible patterns commonly exhibited by middle latitude upper air westerly waves. So basically we have at one extreme almost no waviness at all. That's a zonal pattern. And at the other extreme we have meridional, which is very wavy. There's a lot of north to south movement and distinct crests and troughs. All right, so I'm going to switch that out. These are both the same figures that you just saw. This one is our zonal pattern. And this one is meridional. And we're going to use those and discuss a little bit more in just a minute. Okay, so for number 4, it says when the upper air westerly flow pattern is zonal, the source region for much of the air over the coterminous United States is the Pacific Ocean. Coterminous is like a fancy way of saying over the continuous United States, the lower 48 states. Okay? So went ahead and got a map, and this is what they're trying to tell you. When you have a zonal pattern, and there's not a whole lot of variation, most of what we're getting over the United States is ultimately coming from the Pacific Ocean, because the Pacific Ocean is out west of the United States. So in a zonal pattern, the source region for much of our air is the Pacific Ocean. On the other hand, when the upper air westerly flow pattern is meridional, the source regions for air masses over the lower 48 states are Canada, where the winds are from the northwest, or Mexico or the Gulf of Mexico when the winds are from the southwest. Okay, so this would be the situation in the United States with a meridional pattern. Okay, and you can see that this area of the United States is receiving air from Canada, so probably cold air. And this area of the United States, up the East Coast, is receiving warm, moist air from the Gulf of Mexico. Okay, and it's just because we have more waviness in a meridional pattern. Okay, so let's answer the question number 4. Hence, from west to east across the lower 48 states, temperatures are likely to be more variable with what, a zonal or a meridional flow pattern. So I think you guys can probably tell with these two diagrams, if the Pacific Ocean is the source for pretty much the whole United States in a zonal pattern, then there's not going to be a whole lot of variation here. But when we have a meridional pattern, we have a great deal of variation as to who's getting what in what region. So Temperatures are likely to be more variable with a meridional flow pattern. So that's the answer to number 4. Let's go to number 5. Fundamental to the formation of the polar front jet stream within the westerlies is the physical property that warm air is less dense than cold air when both are at the same pressure. Air pressure drops, more or less rapidly? Okay, air pressure drops more rapidly with increasing altitude in cold air. Do you remember exercise 5B that we did with the little pressure blocks? Okay, as we go up in altitude, we noticed that in the cold air, pressure was dropping more quickly. So number 5, air pressure drops more rapidly with increasing altitude in cold air than in warm air. Okay, and then join me for the last screencast and we'll do the last couple of questions.